Now we're going to define our own navigation theme. So here in the navigation folder, let's add a new file called navigation theme.js. First, we have to import default theme from React Navigation. React Navigation/native. Now, default theme is just an object. It's just a regular JavaScript object with a bunch of properties. We want to copy all these properties and override one of them. How do we do this? Using the spread operator. So let's create a new object. Here we're going to spread the default theme object to copy all of its properties. And then we're going to override colors. Now, colors is a complex object, so it has a bunch of properties. So here we have to copy all the properties in default theme.colors and then override a couple of these properties. One of them is primary, which determines our primary color. Here we're going to use our color palette. So colors.primary. The other property we want to override is background. We're going to set this to colors.white. As simple as that. Now we should export this as a default object. So we can do it right here. Okay. Finally, we go to our app.js. This navigation container has a prop called theme. We set it to navigation theme. Let's test our app. So let's go to our login screen. Now we don't have that gray background anymore. And this button here, it's using the same primary color we defined in our color palette. Beautiful. The next step is to build our tabs. So here in the navigation folder, let's add a new file, app navigator. Here we're going to import create bottom tab navigator from React Navigation/bottom tabs. Now we call this function, we get an object, let's call it tab. With this, we can create a tab navigator. So we're going to call that app navigator. First, we start with tab.navigator. We're going to have 3 tabs. So tab.screen. The first tab is our listings tab. The component for that is listings screen. Let's duplicate this a couple times. Now our second tab is listing edit. And the component is listing edit screen. And finally, the third tab is account, which we set to account screen. Now, because we're using JSX here, we have to import React on the top. And let's separate and sort our import statements. Good. Finally, let's export our app navigator. All right, we're done with this. Now let's go to app.js. We're going to replace this auth navigator with app navigator. Now in the future, when we implement authentication, we're going to render one of these navigators depending on the authentication status of the user. So if the user is logged in, we're going to render an app navigator. Otherwise, we're going to render an auth navigator. Okay. So let's test our app. So here we have 3 tabs. Our tabs are working perfect, but now we cannot navigate to the listing details. We're going to implement that next. So our first tab needs a stack navigator. So here in the navigation folder, let's add a new file, feed navigator.js. Now to save time, I'm going to go to auth navigator and copy these 2 statements. So we are importing React and create stack navigator. Now let's create a stack navigator. With this, we're going to create our feed navigator. First, we add stack.navigator. Now here we're going to have 2 screens. So stack.screen. The first screen is our listing screen. So the component is listings screen. Now let's duplicate this. The second screen is our listing detail screen. Okay. Now finally, we need to export the navigator as a default object. Now we need to go to our tab navigator, which is this app navigator, and replace this component with the navigator that we just created. So feed navigator. Also, for consistency, it's better to rename this route to feed. That's better. Now, back to our app. So when we tap on this, nothing happens because our cart component doesn't respond to the press event. So let's go to cart.js. Look, we don't have the onPress prop here. So let's add it real quick. I'm going to wrap everything with a touchable without feedback. You could also use touchable opacity. I just prefer to use a touchable without feedback here. Now, here we should handle the onPress event and delegate it to the function that we get from the outside. So the consumer of this component should decide what should happen when the user taps on this component. Now, who is consuming this component? Our listing screen. So let's go to listing screen. Here's our cart component. So we should handle the onPress event. Now in this function, we want to take the user to the listing detail screen. So because this is a screen that we registered with our navigator, here we have access to the navigation prop. So here we can call navigation.navigate to listing details. Now, as the second argument, we need to pass the listing that we want to display. So that is this item that we're currently rendering using the cart component. So let's pass the entire listing object. Now, back to our app, we tap on this. Here's our listing details page. But if we tap on this second item, we see the same result because we have hard-coded these values. So let's go to listing details screen. Once again, because we have registered the screen with our navigator, here we have access to the route prop. So now we can get the listing we want to display. So listing equals route.params. Now, here we should replace the source of this image with listing.image. For the title, we're going to use listing.title. And for the price, we're going to use listing.price. Let's save the changes and test our app one more time. So now we're displaying the listing dynamically. Beautiful. One more thing before we finish this video. Here in feednavigator.js, here's our navigator component. This component has a prop called mode. It can be one of these values, cart, which is the default value, and it gives us this kind of transition. So the new screen pops from the right side. Now we can set this to modal, and the new screen will pop from the bottom. Take a look. So look, one more time. That's pretty cool. Now with modal, we can pull this down. That's really nice. Now let's make this even better. Because we're using modal here, we no longer need the back button. We also don't need the title either. So for the listing detail screen, let's apply an option. Here we're going to set header shown to false. So here's the end result. Let's see what we get. Now let's tap on this. Here's our modal. We can pull it down. Beautiful. So let's move on to the next step. So we built a stack navigator for the first tab, but our third tab also needs its own stack navigator. So let's add a new file, account navigator.js. Now to save time, I'm going to go to feed navigator, copy all the code here, and then paste it in our new navigator. Now on the top, I'm going to remove these two import statements. We don't need these screens. Next, I'm going to rename feed navigator to account navigator. Now for this navigator, I'm going to use the default mode. So I don't want to use it as a modal. Now what screens do we have here? Well, we have the account screen, and from here we can transition to my messages. So the first screen is account, and the component is account screen. The second screen is messages, and the component is messages screen. Now here we don't need the options, so let's simplify our code. We're done with this navigator. Now we should use it in our tab. So we go to app navigator.js. We're going to replace account screen with account navigator. Okay. Now we should go to the account screen and handle the onPress event for this list item to take the user to the messages screen. So let's go to account screen. So here we have a flat list where we're rendering a bunch of list items. Each list item has a title, an icon, and so on. So here we need to handle the onPress event. And this is where we need to take the user to the second screen. But here we don't want to hard code the target screen because each list item should specify its own target screen. So on the top, this is where we're defining our menu items. So here's the menu for my messages. Let's give it a new property called target screen. We set this to messages. Now, where we handle the onPress, we need the navigation object here. So let's get it from the props, navigation. And finally, here we're going to call navigation.navigate to item.target screen. Let's test our app. So let's go to the messages. Beautiful. Now, currently we don't have this screen, my listings. So if we tap on it, we get this error. But let's not worry about it. We can always add it in the future. So we have completed all the steps. Now the final step. We want to make these tabs pretty. So for each tab, we want to add an icon. And for our middle tab, we want to have a big, beautiful round button. Let me show you how to implement this. So here in the app navigator.js, first we're going to import material community icons from expo/vector icons. Now, for each screen or each tab, we want to set the options prop to an object. Here we set tab bar icon to a function that returns an icon. So material community icons. For our first tab, our icon is home. And for color and size, I'm going to get these from the props, color and size, and apply them here. So rather than hard coding a value, we're going to use what React navigation gives us. This will make sure that the icon has the right color and size. Now, let's repeat this for the other tabs. For the second tab, our icon is +-circle. And for the third tab, our icon is account. Let's test our app. So here's what we get. Beautiful. Now for the middle tab, we're going to have a big round button. So here's our tab. Instead of tab bar icon, we can set tab bar button to a function that returns a React element. So let's create a new component that represents a round button. So here in the navigation folder, let's add a new file called new listing button.js. So I'm not going to implement this inside our components folder because this is not a component we want to reuse somewhere else in our app. This is purely for our navigation structure. It's only used on our tabs. So I want to encapsulate all the details about the navigation inside this folder. Okay. Now let's create a component. Here we have a view as the container. We want to make it round. So let's apply a bunch of styles. First, I'm going to set background color to colors.primary. Now let's give it a height of 80 pixels and a width of 80 pixels. Now to make it round, we have to set the border radius to half the size. That is 40. Now save the changes. Back to App Navigator. Here for tab bar button, let's render a new listing button. Okay, now preview the app. Here's what we get. Let me resize the simulator. That is better. So look, the button is so close to the bottom of the screen. So first we want to push it up. So back to our button. I'm going to set the bottom to, let's say 20. Okay, Now we have some space here. That looks better. I also want to apply a border around this button. So currently, we have this weird effect. It would be nicer if this white area continued along the top of the circle. So here we set border color to colors.white and border width to 10. Again, I'm trying to sort these properties to make my code more readable. Now, let's take a look. So we have this border around our circle. That looks better. Now we want to add a plus icon in the center of the circle. So first we need to set align items to center. Then we set justify content to center. Next, we import material community icons. We actually need a code snippet for this because we import it all the time. So we import it from Expo and then render it inside our container. So the name is plus circle. The color is white. So I set it to colors.white, and the size, I'm going to set it to, let's say 30. Save the changes. Let's see what we get. So our icon is a bit small. Let's make it 40 pixels. I think that's better. Now when we tap on this, nothing happens because this view doesn't handle the onPress event. So we need to wrap it inside a touchable component. Let's say touchable opacity. Now here we handle the onPress event and simply hook this with the props. So we let the consumer of this component to decide what should happen when we press this button. Okay, now back to our app navigator. So here we want to handle the onPress event. At this point, we want to take the user to the listing edit screen. So here we need the navigation object. Where do we get it from? Well, earlier I told you that this options prop, we can either set it to an object or a function that returns an object. So if we set it to a function that returns an object, now in this function, we get the navigation and route props. So React Navigation automatically injects these props for us. So we don't need the route. Let's just use the navigation. Now we need to wrap the braces inside parentheses. Otherwise, they represent a block of code and not an object. So we need another parenthesis here. Finally, when the user taps on this button, we're going to call navigation.navigate listing edit. Let's save the changes and see what happens. So tap. Here's our listing edit screen. Okay, everything works perfectly. Now, one last thing. I don't like this header on our listing screen. I think that's unnecessary and it's wasting space. So let's go to feed navigator. Earlier we set header shown to false only for the listing details screen. Now I would prefer to apply it over here as screen options so we can remove the header from both these screens. So header shown is false. Now we no longer need this options object. Delete, save, and here's the final result. We can look at the details. Everything works perfectly. There is one more thing we need to address before moving on to the next section. We should get rid of these hard-coded route names. There are a couple of problems with these hard-coded values. If you have a typo here, our app is not going to work, and the only way to find it is by testing every single feature in the app, whether manually or using automated tests. The other problem is that tomorrow we may decide to rename this route to something else. Then we'll have to come back and rename all instances of this route. So we should store all these routes in a single place in our app. Let me show you. So here in the navigation folder, I'm going to add a new file called route.js. Here we're going to export a default object. I'm going to refactor one of these routes as an example and leave it up to you to refactor the rest. So here I'm going to add a property called listing underline details. I'm using uppercase letters to indicate that this is a constant. Now I'm going to set this to listing details. Now, to prevent other modules from accidentally modifying this property, here we can use object.freeze method. This method will ensure that this object that we're passing here cannot be modified anywhere in our app. Okay. Now, save the changes, back to the listing screen. On the top, I'm going to import routes from, we go up to navigation/routes. Now, let's go back to listing details. So here we can reference routes.listing details. That is much better. Now we have a single place where we are defining this route. If we have a typo, there is a single place we have to fix. And also, if tomorrow we decide to rename this to something else, again, there is a single place we have to modify. Now it's your turn. Go ahead and refactor the other routes in the app. I will see you in the next section. In this section, you're going to learn how to connect your apps to a backend. So we're going to pull down these listings from a node server that I'm going to give you in the next lesson. And also, when posting a listing, we're going to see a progress bar and a beautiful animation at the end. Take a look. So are you excited about this section? Let's jump in and get started. All right, to get started, first download the zip file I've attached below this video. That's the backend for our app. So when you unzip it, you're going to see a Node project like this. Now, don't worry if you're not familiar with Node. You don't have to know Node to be a React Native developer. So open this project in a separate VS Code window because we're going to run this side by side with our React Native app. Now we go to our terminal window and install the dependencies. That was very quick because we have very few dependencies here. Now look at the config folder. Here we have different configuration settings. So let's look at the configuration settings for our development environment. We have two settings here, assets-based URL, which determines where our assets or images are served from. So here we can see the IP address of my machine. You need to replace this with the IP address of your machine. Don't use localhost. It's not going to work. Okay. The second setting is port. This is the port of our web server. 9000 is kind of a unique port, so it's very unlikely that you have another process running on this port. If you do, then you need to come back and change the port here. Just remember, if you change the port here, make sure to update it here as well. All right, now to start our server, we type node index.js. Okay, so my web server started on port 9000. To verify it's working, open up your browser and head over to localhost port 9000/API/listings. So here we have a bunch of listings. These are all stored in memory. So our backend doesn't really have a database. It's a fake backend. I chose to implement it this way because it's a lot faster to get up and running. So you don't have to set up MongoDB and a bunch of other stuff. So remember, if you restart the server, you're going to lose the data you have created. Okay. All right. Our web server is ready. Let's move on to the next lesson. To call APIs, we're going to use a popular library called API Sauce, which is essentially a wrapper around Axios. You're probably familiar with Axios. It's a very popular library for calling APIs. I talked about it in my React course. Now, if you have other preferences, if you prefer to use the fetch API, that's totally fine. But in this course, I'm going to use API Sauce. So API Sauce is a wrapper around Axios. It also gives us standardized errors and the ability to transform request and response objects easily. The reason I personally love API Sauce is that whenever we call the server, the underlying promise is always resolved, even if we have an error. So we don't have to add a try-catch block in our code. We just take the response and check to see if there is an error. So let's install API Sauce. All right, the version I'm using is version 1.1.1. Now, here in the app folder, let's add a new folder called API. This folder is going to encapsulate all the code for talking to our APIs. So first, let's add a new file called client.js. Here we import the create function from API Sauce. We call it and give it a configuration object. Here we specify our base URL. Make sure to spell URL with capital letters. I have made this mistake before. I spelled it like this and things didn't work. So base URL, we set this to the URL of our backend. So on my machine, that is 192.168.0.14, port 9000/API. Once again, don't use localhost here because Android virtual device is not going to be able to see your API. Okay. So we call the create function. This gives us an API or API client object. Now, here we have methods like get, post, put, delete, and so on. Now, what I love about this library is that whenever we call the server, the promise is always resolved. So let's say we call the listings endpoint. Now we get a promise. When this promise is resolved, we get our response object. So instead of using a try-catch block to handle a rejected promise, we just check response.ok. If it's not okay, then look at response.problem. Problem is a string, and it can be one of these values. For example, we have client error, server error, connection error, and so on. So API source gives us standardized errors. That's another reason I love this library. Next, I'm going to talk about creating an API layer. So you learn how to call APIs using API source. Now, a lot of people write code like this in their components or screens. This is a bad practice for a number of reasons. First, we shouldn't hard code our endpoints for the same reason we shouldn't hard code our routes. Now, we can improve this code by moving this endpoint somewhere else, but still, our components shouldn't know how they should get their data. They shouldn't know anything about the HTTP protocol. They shouldn't know if they should send a post or a put request. They shouldn't know anything about setting HTTP headers and so on, because this violates the separation of concerns principle. Our components should have a single responsibility, and that is the UI. What the UI looks like and how it behaves when the user interacts with it. How the data comes is not the responsibility of a React component. A React component should talk to another object and say, hey, give me the listings, or save this listing. How that happens under the hood should be hidden from a UI component. What endpoint we call, what HTTP verb we use, what headers we set, our components shouldn't know anything about any of these details. So that is why we need a separate API layer. Our component should talk to this API layer to get or save the data. That is proper architecture. So here in client.js, let's remove the last line. We just create an API client and then export it as a default object. Now, here in the API folder, let's add a new file called listings.js. First, we import our API client from the current folder. Next, we create a function called getListings. This is where we implement the logic for getting the listings from the server. So in this function, we call client.get and pass our endpoint. So this logic should be encapsulated in our API layer. It should be hidden from our components, okay? Now, because we're going to reference this endpoint multiple times in this file, I would prefer to store it in a separate constant. So if we need to change it in the future, there is a single place in our code we have to modify. Now, let's use that here. So here's our function. Now we can export it right here, or we can export a default object. And in this object, we can add all the methods we want to export. What approach you choose is entirely up to you. This is how I prefer to export my API functions. So we have a very simple API layer. As we go through the course, we're going to extend our API layer. Next, I'm going to show you how to use our API layer in a component. So now that we have an API layer, let's get these listings from the server. So we go to listings screen.js. First, we import our listing API. We go up to API/listings. Next, we should get rid of this hard-coded array. We don't need it anymore. So delete. Now in this component, we should declare a state variable to store the listings that we get from the server. So useState, we're going to initialize it to an empty array and call it listings. Now we should call our API the first time our component gets rendered. So we use the effect hook, we give it a function, and this should be executed only once, the first time this component is rendered, okay? Now in this function, we're going to call listings API that get listings. This returns a promise. We can await this, but as you know, we cannot pass an async function to the effect hook. So let's implement this logic in a separate function called load listings. An async function, and here we call our API. We await the call to get the response. Now, this response object has a property called data, which contains the data we get from the server. So here we call set listings to response.data. Now here we should call load listings. So this is how we can get the data from the server. But there are two places we have to modify, otherwise our app is not going to work. Look at this image prop of the card component. We're setting this to item.image. But the array of listings we get from the server doesn't have an image property. It has images, which is an array of objects. Every object has two properties, URL and thumbnail URL. Now in our current implementation, we know that every listing has at least one image. So we should set this to item.images_of0.url. Also, it is better to rename this prop to image URL. This makes our code more consistent. And also, when using the card component, we know that we have to give this prop a string object, a URL, okay? Now, let's go to the card component. This image prop is not renamed, so we have to rename it here as well, image URL. VS Code gave this an alias. We can get rid of the old name and just use the new name. And one last change is on this line, where we set the source of this image. So we cannot pass a string here. We should pass an object with the URI property, okay? Save the changes. And here are the listings we get from the server. When calling APIs, sometimes things don't work as we expect. So to troubleshoot issues, we want to know if our API was called or not. And if yes, we want to look at the request and response objects. To do that, we're going to use another debugging tool called React Native Debugger. You can simply Google React Native Debugger to find this GitHub page. So React Native Debugger is a standalone app based on official debugger of React Native, and it also includes React Inspector and Redux DevTools. So it combines 3 debugging tools inside a single standalone app. Now, on this page, look at the installation instructions. If you're on Mac, you can install it using Homebrew. It's really easy. Just execute this line in the terminal. This would put React Native Debugger in your applications folder. Now, if you don't use Mac, go to the release page. Here you can find the latest release. On this page, you can see various distributables for different operating systems. So we have executables for Windows, we have DMG, and so on. So download and install React Native Debugger. The first time you open React Native Debugger, you see something like this. So here we have 3 debugging tools in one place. We have Chrome DevTools, Redux DevTools, and React DevTools. Now we can toggle any of these tools if we don't need them. For example, we can right-click here and toggle Redux DevTools. Now it's gone. We can bring it back. Super easy. Now here we see this message, waiting for React to connect. The reason we see this message is that our app is not connected to this process. Look on the top. React Native Debugger is trying to connect on this port, 8081. We have to open a new window and change the port number. So on the top, under the debugger menu, go to new window and change the port number to 19001. Now we need to enable remote debugging in our app, so our JavaScript code gets executed inside this process. So here's our app. Let's enable remote debugging. Good, we are connected. Now to inspect network requests, first you have to right-click somewhere and enable Network Inspect. With this, we can find our API requests under the Network tab. So let's reload the app. All right, here's our API call. If you have too many calls here, you can always filter by XHR. So here's the call to our listings API, and Here's the response from the server. Now, as I told you in the first part of this course, remote debugging makes your app slow. So when you're done with your work, go back to the app and stop remote debugging. Whenever we go over the network, we should always count for errors. So let's see what happens if we shut down our server. So in our backend window, let's press Ctrl and C to shut down the server. Okay, now let's restart the app and see what happens. We got a blank window, not a good user experience. Here we should tell the user that we couldn't get the listings from the server and then give them a chance to retry. So back to our listing screen, here we should declare another state variable. We initialize it to false and call it error. We could also call it has error, but I prefer error because that is shorter. So error and set error. Now, when we call the server, we get a promise. This promise is always resolved even if we get an error. So that means we don't have to surround this code with a try-catch block. That is one of the reasons I personally love API sauce. So we get a response and then check the OK property. If OK returns false, that means we have an error. So here we call set error to true. Now we can find the type of the error from response.problem, which can be one of these values: client error, server error, timeout error, and so on. In this case, we don't really care about the type of the error. We just want to tell the user, hey, we couldn't get the listings from the server. So we don't need the response.problem. We set the error and return. Or we can combine these two statements into a single statement and then get rid of these ugly braces. That is better. So as a best practice, always write the error handling code first because that is very important. Now, if you don't have an error, then we're going to set error to false. Now, finally, we're going to conditionally render an error message based on the value of this variable. So above our flat list, if we have an error, then we're going to render a fragment. Inside this fragment, I'm going to add an app text and say, couldn't retrieve the listings. Now below that, we can add a button. Here we set the title to retry and onPress to this function we created earlier, load listings. So once again, we're going to go to the server. If we have an error, we're going to display it. Otherwise, we're going to show the listings. So here we call load listings. Save. Now here's our app. We have our error message, but the button we have here is not the button we have created. It's the button component in the core of React Native. So on the top, let's remove this button component. We're going to import button from components/button. Take a look. That looks better. It aligns with the look and feel of our app. So let's retry. Nothing happens. Now here in the backend window, let's restart our server and then retry. Our listings are back. Beautiful. As part of building your apps, you should always test them and see how they behave with a slow network connection. So let me show you how to simulate a slow connection using React Native Debugger. So I've got React Native Debugger open, trying to connect to this port, 19001. Now on the network tab, we have this drop-down list, which is set to online by default. Here we have a few presets for changing our connection. We can use a fast 3G, a slow 3G, or take the connection offline. We can also create our own custom profile. So here we can set a custom download or upload speed, as well as a latency. For this demo, I'm going to use a slow 3G connection. Now we have this icon over here saying network throttling is enabled. So this is going to make our app really slow. Take a look. So here's our app. First, we have to enable remote debugging. Because we're on a slow connection, downloading our JavaScript bundle is going to take a few seconds. But when the app appears, we're going to see a blank screen for 2 seconds before we see the listings. Take a look. So here's a blank screen. We don't have the listings. They appear 2 seconds after. It would be a lot nicer if we showed the user a loading animation while getting the listings from the server. I'm going to show you how to do that next. To display a loading animation, we're going to use a component called Activity Indicator. This is defined in the core of React Native. So back to our component, let's declare another state variable. We initialize it to false and call it loading. We could also call it isLoading if that's what you prefer. I prefer loading because that's short and sweet. Now, in this function, before we call the server, we're going to set loading to true. And when we're done, we're going to set it back to false. Now, I would like to add a line break here to separate these statements. So I'm treating these three statements as one story because they're highly related. So we call a server, and during this time, we control the loading animation. That is one story. Next, we have another story. If you have an error, you want to show it. And finally, we have another story in case we don't have an error. So with these line breaks, we can separate different stories in our code. Now, here's our flat list. Just before that, we're going to add an activity indicator. So look, this component is defined in React Native. Let's import it. Now here we have a prop called animating. We should set this to loading, so the animation will only appear when we're waiting for the server. But in this demo, let me set it to true, so you can see it at all times. Okay, here's the animation. It's very small. We can change the size to large. That's better. But quite frankly, this animation is pretty boring. In the next lesson, I will show you how to create a beautiful activity indicator. Let's talk about Lottie. Lottie is an animation library built by Airbnb, and it allows us to add beautiful animations to our apps, just like the animation you see over here. This animation is just a JSON file exported from Adobe After Effects. If you don't know how to use After Effects, don't worry, I don't either. Just go to lottiefiles.com. Here you can find thousands of beautiful animations made by people around the world. Most of them are free, but some of them you have to pay for them. Let's look at a few examples. So under animations, let's look at recent. So various animations in different styles for different purposes. Let's say we're looking for a loading animation. On the top, we search for loading. Here are various loading animations. Let's say you like this animation, but you don't like its color. You can easily customize it. So we select this. If you like it the way it is, you can download the JSON file straight away. Otherwise, you can customize it here. So let's go to Edit Layer Colors. So look, on the left, we have various layers of this animation. This animation has a single layer. Here we can see the colors used in this layer. So let's change that to green and update. That looks better. We can also customize the dimensions and the speed of this animation. So we go to Lottie properties. We can change the width, height, frame rate, and duration. When we are done, we go to export as Lottie JSON. We download this JSON file, add it to our project, and then render it using a special component in Expo. So in Expo, we have this component called Lottie, which is implemented in this library, Lottie React Native. Now, at the time of recording this video, we have a known issue. Importing Lottie 3 files causes the previewer to crash without a visible error, because Expo relies on Lottie React Native version 2. Be aware of this issue. Sometimes the animations you download from Lottie files are built for Lottie 3. So if you use them, your app crashes without giving you an error. I had this problem. It took me a couple of hours to figure out the problem was the animation, not my code. So the current version of Expo I'm using targets Lottie React Native version 2. Hopefully in the future, Expo will target version 3 of this library. So let's install Lottie and use it to build a custom activity indicator. So here in the terminal, let's install Lottie-React-Native. Okay, we have installed this library. Now here in the assets folder, I've added a new folder called animations because we're going to have multiple Lottie animations in this project. Currently, we only have loader.json. This is an animation that I found on lottiefiles.com. I just customized it so it matches the branding of our app. If you're interested, you can download it below this video. Now we're going to create a custom activity indicator. So in the components folder, Let's add a new file, activity indicator.js. Now let's create a component. On the top, we're going to import Lottie view from Lottie-React-Native. Now I want to give this component a prop, visible. We initialize it to false. If this is falsy, we're going to return nothing. Otherwise, we're going to return a Lottie view. So return Lottie view. We set its source. Here we use the require function. We go up to our assets folder, then animations, and pick loader.json. We should also set autoplay and loop to true. We're almost done. We just need to delete the styles object because we don't need it. And that means we should remove this import statement as well. All right, now let's use this component on our listing screen. So we go to listing screen. We're going to replace this activity indicator with the one that we just created. So instead of animating, we're going to set visible to true, and we should remove the size prop. Now to demo this, I'm going to temporarily comment out the flat list. You will see why in a second. So let's go to the top, get rid of this activity indicator, and use our own. So import activity indicator from, we go up to components and load it. All right, now let's test our app. So here's our animation. It looks much better than the activity indicator in React Native. Now, one thing you need to understand here is that Lottie view takes the entire screen and renders the animation right in the middle. That is the reason why I commented out the flat list, because if the flat list was there, it would cover the animation. Now we're going to bring it back. So it's right here. Let's bring it back and set the visible prop to loading. So now that we're done with our activity indicator, let's set the network connection back to online, which is the high-speed connection, and disable remote debugging. All right. So we're done here. Let's move on to the next lesson. So here's the typical implementation for calling APIs, handling errors, and showing activity indicators. Now there is a problem with this implementation. Can you tell? The problem is that every time we want to call the server to get some data, we have to repeat this pattern. First, we have to declare a few state variables, and then we have to repeat this logic. All the steps except the API we're going to call are the same. Unfortunately, a lot of people write code like this without ever stopping and asking themselves if there is a better way. Of course, there is a better way. We use hooks. With hooks, we can encapsulate some state and logic around that state inside a reusable function. So here we have some state and some logic around that state. We can encapsulate all these details inside a reusable hook. Let me show you. So in the hooks folder, let's add a new file called useAPI. With this hook, we're going to call our API endpoints. So we export a default function called useAPI. Now, back to our component. Let's grab our state variables. We move them to our hook. We also grab the load listings function. Let's paste it here. Now we need to rename these variables. We don't want to call this listings. We want to have a more general name. So let's rename it to data, and this function to set data. That's better. We should also rename this function. Let's call it request. So this represents a request to the server. Okay. Now, because we're using the state hook, we need to import it on the top. So import useState from React. We're almost there. Now, in our request function, we don't want to call this particular API. We should be able to call different API functions. So let's give our hook a parameter. We call that API func, and then call it right here. Now we should expose this request function outside of this hook so our components can call it. So at the end, let's return an object. In this object, we're going to have a bunch of properties. One of them is the request function, but we should also expose our state variables, data, error, and loading. Our components need access to these variables. So real quick, let's add data, error, and loading. Okay, we're done here. Now back to our component. Let's use our new hook, use API. The API we're going to call is listings API.getListings. Now note that I'm not calling this function. I'm just passing a reference to this function. We are wrapping this function inside the request function. So this is where we actually call the target API function. Okay. Now back to our component. Use API returns an object. We can destructure it and pick data, error, loading, and request properties. Now we can rename request to load listings. And now this function is exactly like the load listings function that we had earlier. Similarly, we can rename data to listings. Now everything should work just like before. Let's save the changes and reload our app. Perfect. Now, what if this API function we're going to call has parameters? For example, let's go to listings API and add 3 parameters here, A, B, and C. It doesn't matter what these are. So how can we pass arguments for these parameters? Well, we go to our hook. Here's our request function. We can use the REST operator to allow this function to take 0 or more arguments. So we call that args. With this REST operator, we get all these arguments and put them inside a single array. Now, we can spread that array when calling our API function. So spread args. Now, back to our component. We rename the request function to load listings, so we can easily call it with different arguments. Okay. Now, one more thing before I finish this lesson. What if you want to call multiple APIs in a single component? We cannot declare multiple variables called error and loading. Well, in those cases, we shouldn't use object destructuring. So let's get the object that is returned from this function and call that getListings API. Now, this object has a few properties. So instead of load listings, we can call getListings API.request. Instead of error, we can call getListings API.error. Similarly, here we can reference getListings API.loading, and finally, getListings API.data. So this is another way of using this hook. The approach you choose is entirely up to you. You can work with a single object or destructure this object into multiple variables. So with this hook, we have encapsulated all the logic for calling APIs inside a single reusable function. We don't have to repeat all these steps every time you want to call the server. All right, the first step is to post the data to the server. So we're going to extend our API layer and implement the ability to post a listing to the server. So here in the API folder, let's go to listings.js. Before we get started, I'm going to remove these parameters. We don't need these. That was just for a demo. So here we're going to add a new function called add listing for posting a listing. So we give it a listing object. And here we're going to use our API client to post this listing to the server. Now in HTTP protocol, each request has a special header called content type. You're probably familiar with it. With this header, we tell the server what kind of data we're going to send in the request. For example, when we send a JSON object to the server, the content type is automatically set to application/JSON. Now for uploading files or images, we have to use a special content type called multipart/form-data. This tells the server that we're sending a large request and the body of the request is divided into multiple parts. Now in this case, we're not going to manually set the content type header. Instead, we're going to create a form data object in JavaScript. When we send a form data object using API sauce or Axios will internally set the content type to multipart/form data. So let's create a form data object. We call it data. Now, this object has a bunch of methods. We can use the append method to add a new key value pair. The first one is title. We set it to listing the title. Then we add price. Next, we set category ID. That's another property that the server expects. Now, our listing object has a property called category, which is an object itself, and has this property called value. Now, in the future, we can change this to ID to be more consistent. But for now, let's not worry about it. That's not the purpose of this step. Next, we add description. Now, each listing has one or more images. So here we need to iterate over images array. We can use a traditional for loop, or we can use listing.images.for each. That's what I prefer. So we pass a function here. Image goes to. Here we call data.append. The key is images. And the value is an object with 3 properties. Name, which should be unique. To generate a unique name, I'm going to add a second parameter to this function called index. And then use it to generate a unique name like this. So name is image plus index. Now we should set the type to image/JPEG and the URI to the image itself. So this image is a string that represents the URI of an image on the user's device. Okay. So we're done with the images. Now each listing can optionally have a location. So here we check if listing has location, then we call data.append location. Now for the value, we have to serialize the location object as a string. Otherwise, the server is going to give us an error. So JSON.stringify listing.location. Okay. So our form data object is ready. Now we call client.post. We're going to post it to listings endpoint, or we can use the endpoint constant that we created earlier. Now, this post method returns a promise, so we should return it from our API function as well. And finally, we need to expose our new API function, add listing. We're done with this step. Next, we're going to call this API to post a listing to the server. Now, in listing edit screen, first we have to import our API. So import listings API from, we go up to API/listings. Now we jump to our component. I just discovered a shortcut today I'm going to share with you. On Mac, it's Shift, Command, and period. This shows different objects in this file, so we can quickly jump to validation schema, categories, our component, and so on. On Windows, it's probably Shift, Control, and period. So let's jump to our listing edit screen. Okay, so here's our form. Now we should replace this inline function with a function reference. So let's call that handle submit. Now we implement it here. Handle submit takes values, or we can call it listing to be more explicit. Here we're going to call listings API.add listing. Now look, the reason I like to export my API functions using a default object is that here it's completely obvious that we're making an API call. If we exported add listing on its own and then imported it in listing edit screen, our code would end up like this. Now it's not clear that we are making an API call. What is add listing doing? Is it adding the listing in memory cache for this app, or is it calling the server? It's not clear what this function is doing. So that is the reason why I like to export my API functions using a default object. So here we call listings API, then add listing. Now this listing object that we have here doesn't have a location property because location is not part of our form. It's a separate object that we get using the location hook. Now here we have 2 choices. We can set listing.location to this location object, but I'm personally not a fan of this approach because I believe we shouldn't touch this argument. We shouldn't touch this object that Formic gives us. So I would rather pass a new object here. First, we spread the listing object to copy its properties, and then we add the location object. Okay. So we call this function awaited and get the result. Now let's make this async. Now, if result is not okay, we're going to tell the user could not save the listing. And then we're going to return. Or as I told you before, we can combine these two statements and get rid of these ugly curly braces. That's better. So otherwise, we're going to tell the user success. That's enough for now. We don't want to worry about a progress bar or an animation. We just want to focus on a single step. So as I told you before, always try to implement a feature in a series of baby steps. Focus on a single task at any point in time, okay? So let's test our app. Save the changes. Here's our app. Let's add a new listing. Okay, post. Beautiful. We successfully posted the listing to the server. Next, I'm going to show you how to track the upload progress. Now let's talk about tracking upload progress. So here in Listings API, where we post this object to the server, we pass a third argument to this method. This is an Axios configuration object. Here we have a property called onUpload progress. We can set this to a function that takes a progress object, and here we log the progress on the console. Now when we send this request to the server, this function gets called repeatedly while the request is being sent. So let's test our implementation. Here we have to manually reload because fast refresh doesn't take into account the changes we make to this file. It only works for our UI components. So let's reload and add a new listing. Okay. Now let's take a look at the console. So this project object has 4 properties. Is trusted, links computable, loaded, which is the number of bytes uploaded, and total, which is the total number of bytes. So now we can easily calculate the progress using an expression like this. Progress.loaded divided by progress.total. Now, let's try it one more time. So manual reload and add a new listing. Okay. Take a look. So here's our progress. We can multiply this by 100 to get the actual percentage and display it to the user. But the progress bar component we're going to add soon requires a number between 0 to 1. So I'm not going to multiply this by 100. Now, there is a problem. With this implementation, we have access to the progress in our API layer. But at some point, we need this value in our UI layer, in our components. So how can we tell our UI components about the progress? Well, we're going to use the same technique we use in React. So in React, if we have 2 components, let's say a parent and a child, let's say something happens in the child and the parent needs to get notified. How do we implement this? The parent sends a function to the child and the child calls that function when something happens, right? This is what we call raising an event. So back to our listing edit screen, this is where we're calling our API. Our first argument is an object. Now, as the second argument, we're going to pass a function. This is a callback function. So our API layer is going to call this function back as the upload is progressing. So let's add a function. Progress goes to console.log progress. Now, back to our API. Let's add this new parameter here. We call that onUpload progress. So we're following the same convention we use in React, okay? Now, down here, instead of logging this value to the console, we're going to call onUpload progress function that is passed as the second argument here, okay? Let's test the changes. So reload the app one more time and add a new listing. Okay, now look at the console. We got the same result as before, but this time we have access to the progress in our UI layer, in our listing edit screen. So with this, we'll be able to display a progress bar to the user. The next step is to show the upload screen when the user posts the listing. And by the way, I just realized that I accidentally disabled fast refresh. So that is the reason why fast refresh was not working over the past few videos, and I had to manually refresh. So let's add a new screen in our app called upload screen. Here's our component. Now we want to show the screen as a modal. So let's add a modal here and then move the view inside the modal. Now we want to show the progress bar in the center of this view. So let's apply a couple of styles here. We should set align items to center, justify content to center as well, and flex so the view grows and takes the entire screen. Okay. Now in the center of the view, for now I just want to add a text component. In the future, we'll replace the text with a progress bar. Again, we want to tackle this in a bunch of baby steps. Okay. So let's add our app text component. The area we decided to rename this component to text, but to import it, we still have to use app text because that is the name that is exported from this file. So here we have to manually rename the imported component. So let's rename this to text. Good. Now this component needs a couple of props. One of them is progress. We can give it a default value of 0. And the other is visible. We initialize it to false. So here we're going to render progress times 100 and add a percentage at the end. Okay. Now we want to show the modal only if visible is true. So we set visible prop to visible. Okay. We're done with this component. Now we use it when posting a listing. So we go to listing edit screen. Here we should declare a state variable for controlling the visibility of our upload screen. So use state, we initialize our variable to false and call it upload visible, or we could call it upload screen visible. I think it's a bit too long, so I'm going to go with upload visible and set upload visible. Now we also need another state variable for maintaining the progress, because right now we're just logging it on the console, but you want to store it in a state variable in this component. So one more time, use state. We can initialize the progress to 0. So progress and set progress. Now in our handle submit function, before we call the server, we're going to set upload visible to true. And as soon as we're done, we're going to set it back to false. Now I would like to add a line break to separate these two stories to make our code more readable. It looks easier on the eyes now. Now over here, instead of logging the progress on the console, we're going to call set progress with progress. We're almost done. Finally, we need to render our upload screen. So somewhere in this component, we can add it before or after this form. It doesn't really matter because we're going to hide it initially and show it only when we are posting the listing. Okay, so upload screen, we set progress to progress and visible to upload visible. Let's test our implementation. So let's add a new listing. Okay, post. You saw the progress as a percentage value. So next we'll replace that with a progress bar. To add a progress bar, we're going to use a library called React Native Progress. With this library, we can add beautiful progress bars to our apps. Now, look at the installation instructions. All we have to do is to install this library using npm. There are no additional steps. There are no extra configurations that we have to do to our iOS and Android projects. So even though this library is not officially part of Expo ecosystem, we can still use it in Expo projects because there are no additional configurations that we have to do to our native projects. Okay. Now note that if you want to use a pie or a circle component, you have to install an additional library called React Native Art. In this course, we're going to use a basic progress bar, this one over here. So here in the terminal, let's install React Native Progress. All right, the version I'm using is version 4.1.2. Now, back in the upload screen, we should import everything as progress from React Native progress. Okay, so now we want to replace this text component with a progress bar. We set progress to progress. We can set the color to our primary color. So we import our color palette and use the primary color. We can also give this a width of 200. Let's see what happens. So take a look. Let's add a listing. All right. Here's our progress bar. Beautiful. Now let's see what happens if we post this one more time. Did you see that weirdness? The progress bar goes back and then comes forward. The reason this is happening is because we're not resetting the progress value. So in our listing edit screen, here in the handle submit function, before we show the upload screen, we have to reset the progress value. So set progress to 0. Now take a look. It always starts from 0. Beautiful. So the next step is to show the done animation when the upload is done. We'll do that next. To show the done animation, once again, we're going to use a Lottie view. So here in the upload screen, let's import Lottie view from Lottie React Native. Now we're going to use conditional rendering here. So if this progress is less than 1, we're going to render a progress bar. Otherwise, we're going to render a Lottie view. So if progress is less than 1, then we're going to render a progress bar. Otherwise, we're going to render a Lottie view. Let me save so you can see the new structure. Here's what we have. Now, this Lottie view, we should set its props. So we set the source to, here we use the require function. We go up to assets/animations and load done.json. I gave you this file in the lesson called exercises. If you missed that lesson, you can download this file below this video. Now, we should set autoplay to true, so the animation starts immediately. And then we should set loop to false, because we don't want to repeat this. We want to show it only once. Now, this animation is a bit too big, so we want to apply a style and make it a bit smaller. So we set style to styles.animation. Now let's define the style. So over here, animation is an object. Here we set the width to, let's say, 150 pixels. Okay, we're almost done. There is just one tiny problem. With our current implementation, the moment progress becomes 1, we render the Lottie view. However, our listing edit screen is going to immediately hide the upload screen. So we're not going to see this animation. So back to the listing edit screen. Here in handle submit function, this is where we call the server. When we are done, we shouldn't immediately hide the upload screen. So delete this line. Here we have two scenarios. If we have an error, we want to immediately hide the upload screen so the user can retry. So let's wrap this with a block of code. First, we hide the upload screen, so set upload visible to false. And then we show an alert. Otherwise, if everything goes well, we don't want to hide the upload screen. We have to wait for the animation to finish. How can we find out? Well, this Lottie view has an event called onAnimationFinish. So we can have the upload screen raise an event and tell the listing edit screen that it's done. So here we add a new prop called onDone, which is a function. We're going to call that function over here. So here we raise an event called done, and our listing edit screen should subscribe to this event. So if everything goes well, we don't want to show an alert. We're done with this. Here's our upload screen. We want to handle the done event. So on done, we pass a function, and this is the moment where we should hide the upload screen. So set upload visible to false. That's all we had to do. Let's test our app. So post, beautiful. Let's try it again. Perfect. So the next step is to reset the form. We'll do that next. So let's see how we can reset this form. To solve this problem, I expected you to do some research and find out how we can reset a Formic form. So hopefully you came across this page, Formic API reference. Look at the onSubmit event. The function that we use for handling this event has two parameters. The first parameter is values, which is the values in the form. The second parameter is Formic bag. So Formic bag is an object that contains a subset of injected props and methods. So all the methods with names that start with set, like set field touched, set field value, all these methods plus reset form are available here. Now look at this note. Errors, touched, and status are not included in Formic bag. So back to our code. Here's our handle submit function. Currently we have only a single argument here. Let's add another argument that is Formic bag. So this is an object. We can destructure it and pick the reset form property, which is a function. Now, if everything goes well, then we're going to call reset form. Let's see what happens. So let's post this. All right. Our form is partially reset. So the image and category fields are cleared, but the title and price fields still have a value. However, let's see what happens if we post the form one more time. We got all these validation errors. So internally, we don't have any values for these fields. We just have some values visually appearing on the form. When you face problems like this, always ask yourself, what are the differences between these input fields? So both these input fields are instances of form field component. Category is an instance of form picker component. So let's quickly compare these two components. Here in the forms folder, we have form picker. Let's open it, as well as form field. So here we're using this picker component. We have a bunch of props, but most of these props are irrelevant in this problem. For example, the items that we show to the user, or the number of columns, or the width, these are irrelevant. They have nothing to do with the state of the form. But look at this prop, onSelect item. So when we select an item, in this implementation, we call the set field value function. But in form field, when the text is changed, we use the handle change function. So that is one difference. The other difference is that in form picker, we have this prop, selected item. So we are setting this to the value in the form. But in form field, we haven't set this prop. So to solve this problem, let's bring set field value and values objects. Now we don't want handle change anymore. So these are the properties and functions that we need. Now, to handle this event, we pass a function that takes the text, and here we call set field value. We give it a name and the text values. Next, we set the value. We set it to values of name. So these were the only differences we had between these two components. Let's see if this solves our problem. So save. Let's add a new listing. Okay, post. All the fields are reset. Let's post the form one more time. We get all the validation errors. Let's fill it out one more time to make sure that our form state is maintained properly. Okay, our form is perfectly reset. Internet connection is not always available or reliable. So in this section, you're going to learn how to build mobile apps that can function when they're offline. So we're going to take our app to the next level. If the device is offline, we're going to show an offline notice on the top and load the listings from a cache. So all these listings are still available even if the device is offline. This is a very important topic that a lot of other books and courses overlook. So let's jump in and get started. Let's talk about various strategies for building offline capable apps. There are 4 common strategies we can implement here. We can notify the user that they don't have an internet connection and potentially disable certain features. These are the simplest strategies to implement. Now, in addition to those, we can also cache data so it's available when the device is offline. Now, during this time, If the user performs actions that involve modifying data, we can store these actions locally on the mobile device and then execute them later when the device goes online. So these are the 4 common strategies for building offline capable apps. As we go down this list, the implementation cost increases. So don't try to implement all of these features. Always think about the requirements of your app and what really works for the user. Think about the time, think about the budget, take all these factors into account before picking a solution. So throughout the rest of this section, we'll talk about these strategies in more detail. To notify the user that they're offline and potentially disable certain features, we need to detect the status of their network connection. To do that, we use the NetInfo API in Expo. This API is built by React Native community and is fully supported in Expo. So let's go ahead and add this to our project. All right, now back to app.js. I've cleaned up the code here so we can focus on this demo. So on the top, let's import NetInfo from React Native community /NetInfo. Now, this object has a bunch of methods. We have the fetch method to get information about the network connection. So we call it, we get a promise. Now we can await that promise or call then to get a NetInfo object, and then we can log it on the console. Take a look. Here's what we get. This object has a bunch of properties. We have details, which gives us more information about the network connection. Here we have IP address, is connection expensive, SSID, and subnet mask. We also have is connected, which tells us if we have a network connection. But we have another property called is internet reachable. A lot of people don't know about this property. They just rely on is connected. But here's the catch. Just because there is a network connection available, it doesn't mean that internet is accessible. So you should always check this property. Now currently this property is set to null because NetInfo is trying to figure out if internet is reachable. The way it does this is by pinging a remote server. I think it's Google, but you can always configure this by using NetInfo. So it pings a remote server, waits for a response, and during this time, this property is null. So with the fetch method, we can get information about the network connection only once, and this is not very reliable. So quite often we use another method called add-event-listener. With this, we can subscribe to network status changes. So here we pass a function. This function gets called every time there is a change in the network status. So let's say NetInfo goes to console.log NetInfo. Now take a look. We have 2 objects here. Initially, is internet reachable is null, and then it became true. Now this method returns a function for unsubscribing, unsubscribe. So typically we call this method in component didMount in class components, and then we call unsubscribe in component will unmount. It's really important to unsubscribe. If you don't unsubscribe, your component will keep querying NetInfo API and you're going to end up with memory leaks. So this is how we can use NetInfo in class components. Now in this course, we use function components. So we have a special hook that hides all this complexity. So let's import use NetInfo hook. Now let's call it over here. We get a NetInfo object. All that subscribing and unsubscribing happens under the hood inside this hook. So here we have a NetInfo object. With this, we can show an offline notice to the user or disable certain features. For example, we can check NetInfo that is internet reachable. If it's true, we're going to render this view. Otherwise, we're going to render a different view. That's one idea. Or we might have a button. So we set the disable prop to not NetInfo is internet reachable. So if there is no internet connection, then we're going to disable that button. These are a couple of ideas we can play with. Next, we're going to talk about caching. Now let's talk about caching. So when we call our APIs, we want to store successful request data locally on the mobile device. So if the device goes offline, we can read the data from the cache. We have 3 options here. The first option is async storage, which is pretty much like local storage in web browsers. We use it to store key value pairs. Values are strings and they're not encrypted. So we shouldn't store anything sensitive here. Also, there is a limit of 6 megabytes by default. We can increase it if we want, but generally speaking, you don't want to store large amounts of data on a mobile device because these devices have limited storage. So this is async storage. Another option is to use Secure Store in Expo. This is an API built by the Expo team, and it's available in both managed and bare React Native apps. There is a limit of 2 megabytes, which makes total sense because we shouldn't use this to store large amounts of data. And finally, the last option is SQLite. This gives us a lightweight SQL-like database. So if you need to query data with SQL queries, you want to use this option. Now, with all these options, our data is available across app restarts, but it gets wiped out if the user uninstalls the app. Next, we're going to talk about async storage in detail. Let's talk about async storage. So async storage was initially part of React Native Core, but as you can see on React Native website, now this API is deprecated and it's available as a separate library built by React Native community. However, at the time of recording this video, Expo still uses the old async storage, the one in the React Native Core. Let me show you. So on Expo website, let's search for async storage. Now take a look. So here we're importing async storage from the React Native Core. Now in the future, when you watch this video, this is probably going to look different. So we're going to have Expo install async storage and our import statement is going to look different. So have a quick look at this page before watching the rest of this video. So back to our project, let's import async storage from React Native Core. Now, to store a key value pair, we call async storage the set item. Let's say the key is person and the value is a person object. Now, the value that we pass here should be serialized as a string. So here we call JSON.stringify and then pass a person object. Let's say this object has a property called ID set to 1. Now, this method returns a promise, so we need to await it. Now, for this demo, I'm going to wrap this inside a separate async function. So demo is an async function. Okay. Now we need to wrap this inside a try-catch block because storing this item may fail for a couple of different reasons. Maybe the storage is not available at this point in time or it's full. So let's add a try-catch block and then move this code up here. Good. Now, if something goes wrong, we want to log the error. For this demo, I'm going to log it on the console. But in a real app, we should log this using a login service like Sentry. We'll talk about this in the future. So this is how we store an item. Now, to read it, we call async storage that get item. We specify the key. Now, once again, this returns a promise. So we await it to get the serialized value. This is a string. So we have to call JSON.parse to get the actual person object. And then we can log it on the console. Okay. So here's our demo function. Let's call it right here. Save the changes and then look at the terminal. And here's our person object. Next, I'm going to show you how to inspect the content of async storage. As part of debugging your apps, you may want to look at the content of async storage. Let me show you how to do this. It's really easy. First, we have to enable remote debugging. So debug remote.js. Next, we launch React Native Debugger and have it connect to this port, 19001. We talked about this earlier in the course. Now here in the console tab, we have a special function called show async storage content in dev. There you go. Here's our person object. We can also work directly with the async storage. So here we type $React Native dot. Now here we have access to various APIs in React Native. So we can access async storage and all its methods. For example, we can clear the async storage. Now, if you look at the content of async storage one more time, it's empty. So these techniques are really useful while debugging your apps. Maybe your async storage gets corrupted. You may want to insert a new item or remove an existing item. To do that, just use @reactnative.async storage.